You may have seen Karpathy talk about Wiki Elms, and you may have also seen Google Graph as a direction for knowledge archiving. Wiki Graph is an implementation of those ideas, an open-source CLI tool that turns long texts, such as novels, papers, and documents, into searchable, citable, and traceable knowledge graphs. The important part is that these knowledge nodes are not floating abstractions. Every entity and every relation should be traceable back to a concrete location in the original text. In other words, Wiki Graph does not just produce a nice-looking graph. It produces a graph that can be checked. Next, I will show the effect directly. Once a book becomes a knowledge base, how can we start from the knowledge graph and uncover links that are easy to miss in a normal linear reading? One note before the demo. Wiki Graph is a CLI tool, but I do not expect people to type these commands all day. It is designed to be agent-friendly. The best way to use it is to hand it to an agent and ask your question directly. In this video, I show some command line steps only so that you can see what happens in the background, how the agent queries, expands relations, and returns to source evidence. For the demo, let's use the Great Gatsby. Instead of starting with Gatsby himself or with the green light, I want to start with the yellow car. The yellow car works like a MacGuffin in this demo. It looks like a simple object, but once we use it as a query center, it pulls Gatsby, Daisy, Myrtle, Wilson, and Tom into the same graph. From a knowledge graph perspective, this lets us look at the novel through a slightly different path. We are not summarizing the plot from beginning to end. We are asking how one object roots ownership, action, blame, and consequence. The first thing the graph shows is also the most misleading thing. Gatsby owns the yellow car. If we stop there, the car would seem to point straight to Gatsby. But when we open the evidence, the story becomes more complicated. Daisy was driving, and Gatsby says he will take the blame. So the graph separates two things that are easy to collapse together: ownership and agency. Gatsby owns the car, but Daisy drives it. The accident points to Daisy, while the blame moves back toward Gatsby. At that point, the knowledge graph gives us the important edges, but it cannot fully explain how the consequence travels through the story. So we switch into the reading graph and follow the relevant passages directly. Following that path, Wilson traces the yellow car. Tom gives him the owner. Gatsby absorbs the consequence. And Daisy, who was actually driving, gradually disappears from the blame path together with Tom. Now we can return to the green light. The green light is one of the most familiar symbols in the novel, but after tracing the yellow car, it feels different. Gatsby reaches toward Daisy, but when consequence arrives, Daisy and Tom are the ones who can retreat. So the point is not that Wiki Graph discovers a brand new plot twist. The point is that it gives us an nonlinear reading path through the same novel. Starting from one object, we can move through triples, reading graph paths and source evidence, and see how the novel roots desire, blame, and consequence. In Gatsby, wealth does not erase guilt, it reroutes it. The demo you just saw is only a small slice of the project. The larger question Wiki Graph is trying to answer is, how should knowledge from long texts be produced, preserved, and made usable by agents? Put another way, we do not want an agent to reread a pile of raw material every time. We want long texts to be compiled into a stable, queryable form of knowledge. When Karpathy talks about Wiki Elms, the point is for Amidel to maintain traceable knowledge instead of starting from scratch each time. Google Graph points in a similar direction. It can be understood as a system that moves from raw material to higher-level knowledge work. At the bottom there is source and evidence, meaning the original material and its evidence locations. Above that, there are entity and triple objects extracted from source. Above those there are concept, workflow, and playbook objects that support collaboration and agent use. Wiki Graph sits at the bottom of this system. More specifically, it focuses on the source layer and the step that abstracts source into entity and triple, archiving long texts, preserving source evidence, and generating searchable, traceable knowledge graphs. Higher-level concept workflow and collaboration systems can still build on this material. Wiki Graph focuses on doing the lower-level knowledge tooling well, so an agent can query entities, follow relations, and return to evidence through this layer. So this is not about saying that upper layer problems are unrelated to Wiki Graph. It is a division of responsibility. Wiki Graph acts as lower layer tooling inside the OCF style stack. It manages the source layer and prepares entities, relations, and evidence. When upper layer systems need that knowledge, they do not have to reprocess raw text, chunks, and evidence from scratch. Hey can query and cite through Wiki Graph directly. There is also one design choice here that differs from Karpathy's direction. The Elm wiki that Karpathy describes feels more like a personal or team-maintained wiki. That kind of wiki can be extremely flexible. It can capture your projects, your habits, your naming conventions, and even concepts you define on the fly. But many of those entities and relations live only inside your private context. They do not have public boundaries or common recognized IDs. Wiki Graph takes a lower level and more conservative path. It starts from public entities, meaning it tries to align entities in the text with objects that already exist in public knowledge sources such as Wikipedia and Wikidata. For example, if a person, a book, or a place can be aligned to a stable kid, it is no longer just astering inside one text. It becomes an object that can be reused across chapters, documents, and knowledge bases. The triples, source evidence, and related passages extracted later can then accumulate around the same entity. Of course, this choice has a cost. It will not cover every private concept, and it will not turn every temporary name into an entity immediately. But for Wiki Graph, the most important step right now is to preserve the stable, traceable, reusable knowledge inside the source layer. Private schema can continue to develop at higher layers, while Wiki Graph focuses on getting the foundation of public entities and source evidence right. Wiki Graph is still at a very early stage, and many design choices will continue to evolve. If this direction is interesting to you, you are welcome to try it on GitHub, open issues, or join the discussion.